See, come to black box techniques. First one, equivalence partitioning. Equivalence partitioning. Another name is equivalent classes. Equivalent classes. Equivalent partitioning or equivalent classes. Say, it can be applied at any level of testing: unit testing, integration testing, system and acceptance testing. Okay, our area is system testing. Developers conduct unit and integration testing. Next, end user means customers conduct acceptance testing. Forget about unit testing and integration testing and acceptance testing. Our area is system testing. Okay, equivalence partitioning can be applied at any level of testing. Next, in equivalence partitioning, inputs to the software are divided into groups that are expected to exhibit similar behavior. In equivalence partitioning, inputs to the software are divided into groups that are expected to exhibit similar behavior. Next, equivalence partitions or classes can be found for both valid data and invalid data. See, we divide the input domain into classes or partitions. Then we take one or two inputs from each class. By executing these small number of inputs, we can quickly conduct the testing, reducing the input, at the same time covering all areas. Say, observe the points. It can be applied. It can be applied at any level of testing. Observe, Sri Lakshmi, we have 4 levels of testing now. What are the 4 levels of testing? Say, unit testing. Next, integration testing. Next, system testing, and acceptance testing. In which, what is our area, Sri Lakshmi? Unit testing or integration testing or system testing or acceptance testing? What is our area? System testing. See, as an independent tester, your area is system testing. Usually, developers conduct unit and integration testing. Next, end users conduct acceptance testing. Okay. See, 4 levels of testing. Testing, okay, but testers vary from one level to another. Okay. In equivalent partitioning, next point. In equivalence partitioning, inputs to the software are divided into groups that are expected to exhibit similar behavior. That are expected to exhibit similar behavior. Next point, equivalence partitions. Equivalence partitions, or you can say equivalence classes, can be found for both valid data and invalid data. Can be found for both valid data and invalid data. See, this is the brief introduction about equivalence partitioning. I will provide examples. Before examples, one general topic, data. We use data for testing, input data, test data, data factors. See, we have three important data factors. First one, type of the data. Can you give example for type data type? Krishna Chaitanya, data type.
Integer, float,
integer, character, float, double. Okay, those are technical classification. In general terms, alphabets. Next, say integer, double, character, string. These are technical terms. In general terms, alphabets. Next, alpha numeric, only numeric also. Alphabets, numeric. Next, combination, alpha numeric. Next, alpha numeric and special characters, star, etc. symbols, special characters, etc. See, type of data. For example, phone number object. Phone number object accepts, phone number field accepts 10-digit numeric values. Numeric is type. 10-digit is size of the data. Next, city name. City name field accepts alphabets. That is type of the data. Next, user ID. User ID field accepts alphanumeric values, 10 to 20 characters long alphanumeric values, means alphanumeric is type of the data. Next, Rahman, did you join?
Yes, sir. I'm sorry. I have a time issue.
Cool. No issue. Cool. Next, size of the data. Size. Suppose phone number object or phone number field accepts 10-digit numeric values. 10-digit is size, numeric is type. Suppose 10 digits. Phone number. Next, one more thing. Krishna Chaitanya, can you tell me type of the data, size of the data,
Range of the data.
range of the data, range of the data. Suppose in insurance applications, suppose for 1 lakh policy, premium amount, suppose applicant age 25 to 30 years, premium 5,000. Example, 30 to 35 years, 6,000. 35 years to 40 years, 7,000. What is this 25 years to 30 years? This is range of the data. Suppose in banking applications, 1 to 2 years interest rate for fixed deposits 7%, 2 to 3 years 8%, 3 to 4 years 9%, 5 to 7 years 11%. That is range of the data. Suppose 1 to 2 years, 5 to 7 years. This is range of the data. Okay, now Rahman, data factors. We have 3 data factors: type of the data, size of the data, range of the data. Okay, na?
Yes. Yes, sir.
Okay. Observe the example. Example 1. Here we focus on data range. Data range. Okay. Example is tickets field in a reservation system accepts 1 to 10 tickets only. Minimum 1 ticket, maximum 10 tickets. You can enter 5 tickets, 7 tickets, 8 tickets, but 11 tickets invalid, 0 invalid, 20 tickets invalid. See, tickets field in a reservation system, accepts 1 to 10 tickets only. 1 to 10 tickets only. Here, partitions. See, partition 1, next partition 2, next partition 3. See, testing with all possible inputs and preconditions impractical, so that we use test design techniques in order to reduce the input. Reducing the input at the same time covering all areas. Coverage important, but you have to reduce the input. Why? Otherwise, if you want to execute all possible inputs and preconditions, time taking process. See, due to time and budget considerations, generally we don't go for exhaustive testing. Exhaustive testing means testing with all possible inputs and preconditions. We reduce the input using test design techniques. Rahman, make that range into partitions. First partition, suppose 0. Second partition 1 to 10. Third partition, Krishna Chaitanya?
Greater than 10.
Okay. Suppose 11 to 99 or above. See, first partition we have to take 1 or 2 inputs from every partition, then we can cover all areas. You no need to take all inputs. First partition, Sri Lakshmi, is it valid or invalid?
Invalid, sir.
Invalid. Second partition?
It's a valid, sir.
Valid. This is valid partition. Third partition?
Invalid.
Invalid only. See, this is one example. Here we focused on data range. Next, example 2. Example 2. This time data size. Focus on data size. Sometimes we need to focus on one or more factors. Suppose phone number object takes phone number field accepts 10-digit numeric values. That is our requirement. Here 10-digit is size, numeric values. Numeric is type. Here we need to focus size and type. Okay, in our examples I am focusing data factors one by one. Example 2, data type. Okay. Here example is customer identification number. See, customer identification number, a field accepts only numbers. Customer identification field accepts only numbers. For this one, write partitions Rahman, partition 1, partition 2, partition 1. Krishna Chaitanya. Why nobody responding?
Accept alphabets, like check alphabets whether it is accepting or not.
See first alphabets. This is one partition. Next, numeric or numbers. Next partition, alphanumeric. Alphanumeric. Next partition, see alphabets, numbers, alphanumeric. Next, alphanumeric and special characters. Nandakishore and special characters. Now tell me Rahman, partition 1 as per our requirement, test requirement, partition 1 is valid or not?
Invalid.
Invalid. Next partition 2?
Valid.
Valid. Partition 3?
Invalid.
Invalid. See, partition 3 invalid. Partition 4 also invalid.
Invalid.
Okay, just a minute. Next example, data size, data range, data type, data size. See, example 3.
Sir, I have a question. Is example 2 is a data size or It's a data type.
Oh, yes. It's not size. Data type, type of the data. Good. First one, data range 1 to 10. Next, 0, 11 to 99 or above range. Type. Okay. Good. Data type. Range, type, next size. 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 Suppose phone number field accepts 10 digits only, or 10 digits numbers only, numeric data only. But here we have to focus on 10 digit size, numeric type also, but you concentrate on size. First size. See, phone number field accepts 10 digit numeric data only. Partition 1, partition 2, partition 3. Suppose partition 1, tell me Sri Lakshmi, partition 1. Suppose below 10. Now our focus on size. Okay, for this phone number field, we need to check that number also, means type also. For this phone number field, data size and data type also important. But in our example, I am covering only data size. Already I told some fields having more data factors. We need to cover more data factors. Size and type, next type and range, etc. But I am explaining separately. First, our focus on data range, next data type, next data size. Actually, this for this phone number field, two data factors. What are the two data factors, Rahman? One is
It must be numeric and also 10 digits.
one is size, another is type.
Range.
Not range, type. Type na.
Type. Yeah.
Numeric
Yes,
is
sir.
type of data. See, observe. 10 digit. 10 digit is size. Size of the data. Next, numeric is type of the data. Okay. Okay, focus on data size. Size. Okay. Below 10, this is one partition. Next, 10. Next, above 10. See, first one. Observe Krishna Chaitanya, below 10, valid or invalid?
Invalid.
Invalid. Invalid. Next, valid. Next, invalid. Say, we covered three factors: data range, data type, data size. Next, one more thing also there: others. But nowadays, we no need to cover this one. I will show. Others, here no data, no data type or data size or data range. Example, a payment management system, a payment management system accepts credit card payment only, credit card payment only. Abdul Rahman, here no data size, no data type, no data range. Okay na?
Yes, sir.
Actually, we no need to take partitions. Suppose if any payment management system accepts credit cards only, then they provide only that option. You can check that option only. Just understanding point of view, I am writing this partitions. But nowadays, any payment management system provides only one or two payment options. Then they provide only those options. Suppose net banking not available, that time no net banking option. Suppose cash on delivery option not available, facility not available, no that option. Okay, just understanding point of view I am writing. See partition 1, partition 2, partition 3. Suppose partition 1, credit card, partition 2, net banking, partition 3, suppose cash on delivery. See first one valid, next invalid, next invalid. Okay na Sri Lakshmi? We covered all areas na? See, we discussed data range, data type, data size and others separately. Next combinations. Abdul Rahman, example, user ID. User ID field accepts 10 to 20 characters long alphabets or alphanumeric data. User ID field accepts 10 to 20 characters long alphanumeric data. Here, what are the data factors?
It's data factors.
10 to 20 characters. It accepts
It has
10
a
to
data
20 characters. Suppose you can create user ID with 10 characters or 15 characters or 17, 18, 19, 20, 21 not acceptable, 9 invalid, 21 invalid, 9 invalid. Here first one is data
size, range. Yeah.
range.
10 to 20.
10 to 20. That is range. Next, observe just a minute. 10 to 20. To 20. Next,
Data types.
alphabets. Alphanumeric. Alphanumeric.
It's a data types.
Type. Observe Rahman. 10 to 20 is data type or data size?
It's data range.
Not range. Size of the data only. Suppose 10 digit. Observe. Here no mathematical operations involvement. 10 digit, 14 digit, 18. Suppose 10 digit valid, 14 digit valid, 18 valid, 22 invalid, 8 invalid, 8, 14, 18, 22. This is size only. Range means mathematical operations involved. For example,
Correct.
1 to 45 days, interest rate 5%, 46 days to 180 days, interest rate some 6%. Getting that point?
Yes, sir.
That is range. Okay, next observe. Another example. Already we used. Phone number. Phone number field accepts 10 digit numeric values only. Now observe Sri Lakshmi. Here what are the data factors? 10 digit. What is this one?
Only numeric, sir.
I am asking 10 digit. 10 digit is size or range or type?
It's a size.
Size. Next, numeric.
Type.
Data type. Type. Just a minute. Somebody still making noise. Okay. Example 1. Example 2. Next. Example 3. See, we covered data size, data type. Next, data size type. Both are size type only. Can you give an example for range, data range and other combination? Rahman? Data range. Okay, observe. Customer age field accepts age value from 21 to 65 years. Numeric data. Observe customer age. This 25 to 65 years. What is this one, Rahman?
This one range.
Range. For example, 20 also 2-digit data. 20 invalid, 19 invalid, 66 invalid. This is data range.
Because it's out of range.
Out of range. Data range. Next, numeric. See age 20, 30, 40, 50. This is numeric data. Data type. Data type. Okay, now we covered all possibilities now. Any queries, Krishna Chaitanya? Combinations.
No, sir.
Come to second one. Boundary. Boundary value analysis. BVA. Actually, this boundary value analysis is extension of equivalence partitions or equivalence classes. It is extension of equivalent partitions. Without equivalence partitions, we cannot use boundary value analysis. Getting this point, Sri Lakshmi?
Yes, sir.
It is extension. It is extension of equivalence partitions. Without equivalence partitions, we can't use boundary value analysis. Observe the points. See, the maximum and minimum values of a partition are its boundary values. See, the maximum and minimum values of a partition are its boundary values. Boundary values. Next, behavior at edge of each equivalence partition is more likely to be incorrect than behavior within the partition. Observe. Behavior at edge. Behavior at edge of each equivalence partition is more likely to be incorrect than behavior within the partition. Next, boundary value analysis can be applied at all test levels. See, boundary value analysis can be applied at all test levels. What are the all test levels, Rahman?
Unit integration.
Unit integration. Next,
Integration.
system
Sorry.
and acceptance testing. What is our area as an independent tester? System testing. Okay, next come to example. Okay, you take first example of equivalence partition, this one. For that you write minimum maximum values, Sri Lakshmi. For every partition, minimum maximum. See, in partition 1 we are used only 0 na.
Zero.
Suppose
Yes, sir.
minimum maximum 0 only. So one input is enough for first partition. For second partition, what is the minimum?
Minimum 1, maximum
Minimum 1,
10.
just a minute. Minimum is 1, maximum
10.
10. See, you need to take these two inputs. Minimum 1, maximum 10. For third partition,
Minimum 11 and
minimum
maximum
11.
99.
Next, maximum.
Maximum
Suppose 99 or above. Anyone you can take. See, these inputs are enough to cover all areas. Next, you take that data size 1. Phone number object is there na. This one. Krishna Chaitanya, write boundary value analysis for this one. Suppose partition 1. Here fixed na minimum
0.
any one minimum. What is the edge? 9 na.
Yes, sir.
Next, minimum maximum. Minimum and maximum in partition 2, 10 only. Next, here maximum. Okay, minimum 11 in third partition. You don't need to cover 12, 13, 14, etc. See, 3 inputs enough. 3 inputs enough. Suppose observe one example. User ID. Observe Rahman. User ID field accepts 10 to 20 characters long, 10 to 20 characters. Okay, forget about alphanumeric or some other. You focus on range. User ID field accepts 10 to 20 characters. For that, first divide the partitions. Rahman, first partitions.
Partition is below
Already I told. Boundary value analysis is extension of equivalence partitions. Suppose partition 1, partition 2, next partition 3. Partition 1.
It's below 10.
Below 10, good. Below 10 characters. Next,
10 to 20.
10 to 20. Next,
Above 20.
11 to Suppose 99 or above. Now BVA, boundary value analysis. First, EP, equivalent partitions, or you can say EC, equivalent classes. Equivalent partitions are equivalent classes. BVA, continue Rahman. BVA.
Minimum 9.
For first partition, minimum 9.
9.
Minimum 9.
Minimum, maximum.
Not 9. Minimum 1 na. Maximum
20.
For first partition,
For
minimum 1.
maximum.
Pardon?
Below
10 means, below 10 means what is the maximum value?
10.
Below 10 means
99 or above. That's below.
Don't confuse. Here at least one character is minimum. 0 not considerable. Below 10 at least 1 means below 10 means 9 na, 9 characters na.
Yes, sir.
Here minimum in this first partition, minimum is 1 character, maximum is 9. In second partition, minimum 10.
10. Maximum 20.
Maximum 20. Edge. Next in third partition, minimum 21.
11 or 21.
Maximum
99
99 or above. Observe, first partition invalid, second partition valid, third partition invalid. So definitely this one fail. This one pass. Without using all possible inputs, we can cover all areas using equivalent classes and boundary value analysis. Observe Sri Lakshmi, any confusion?
Sir, in example 2,
How
could the minimum value become 9?
Below 10 means, suppose phone number 10 digit. Here minimum maximum 10 digit only, fixed, no range. Below 10 means how many characters? 9 digit value na.
Okay.
Minimum, say valid is 10 digit. Next below 10 means 9 is below 10, 8 is below 10, 1 is below 10. Okay, here you can I am taking this edge, but you can take 1 also. 1 is minimum. Okay, good. 1 is minimum. Maximum
9.
Okay. Maximum 9. This is first partition. Minimum 1. Try with one digit value. That is fail. That should be fail. Why? 10 digit is the accepted data. That size is 10 digit as per requirement. In this range, minimum 1. 0 means nothing. So minimum 1, maximum 9. Next, second partition, only 10 na.
Yes, sir.
Here minimum, maximum 10. Next, here minimum 11. Okay, maximum suppose 99 or above. If it accepts, okay, actually this one These three enough. Observe, Srilakshmi selected three. We covered below range, after, above range and regular range na.
Yes, sir.
Okay. Any queries, Krishna Chaitanya?
No, sir.
See, next third one, decision table testing. Decision table testing. Say sometimes equivalent classes or partitions and boundary value analysis are not sufficient. When I will explain. See, the decision tables are good way to capture system requirements that contain logical conditions. Logic, if any logical condition is involved, then we need to take decision table. I will show the example. See, the decision tables are good way to capture system requirements that contain logical conditions. Logical conditions. Next, it may be applied for all situations when the action of the software depends on logical decisions. See, it may be applied. It may be applied for all situations when the action of the software depends on logical decisions. Say I will provide example, then you can get more clarity. Observe Krishna Chaitanya. Example, BSRB, Banking Service Recruitment Board. So government, for example, private also, private recruitments also there. Suppose if it is government, some formalities. BSRB system means application under test. BSRB system, clerk or some job. BSRB system, job eligibility criteria. Observe here, requirement is, observe Rahman, requirement is candidate age, where the other eligibilities also their qualification, etc. Now we are focusing on age. Candidate age should be age should be in between 21 and 35. Getting the test requirement, Rahman?
Yes, sir.
If it is like this, then you can easily prepare the input. Here, age is what type of data? Numeric, na?
So numeric data.
Numeric type. Next, 25 to 35 years, 21 to 35 years.
So range.
Range of the data. Okay. If requirement is like this, then you can easily make the partitions based on the data range and data type, and you can find the boundaries and prepare the input, small size of input. Okay, but some conditions for this test requirement, some conditions. See, this is government example, government application, some conditions. First condition, for SC or ST, scheduled castes or scheduled tribes, candidates 5 years age relaxation, 5 years age relaxation. This is one condition. Next, just a minute. For BC, backward caste candidates, 3 years. Next, for PHC, physically challenged candidates, 5 years. See, these are the conditions. Then partitions and boundary values not suitable, na Rahman?
Yes, sir.
Here decision tables required. Suppose category, I'm preparing one small table, category, age, next valid or invalid criteria. Suppose first one, candidate OC, age 20. Observe Rahman, pass or fail, or valid or invalid?
Let's look invalid.
Invalid. Next, SC, age 20, invalid only. Relaxation means after 35 years. Next, suppose OC, 25, valid or invalid?
Valid.
Valid. Just a minute. SC, 25,
Valid.
valid. Valid means pass, invalid means fail.
Fail.
It has to fail. Next, suppose PHC, 25,
Valid.
valid. Next, OC, 36, OC 36.
I don't see any OC condition.
Observe, 21 to 35 years.
Oh, okay.
Remaining 3,
Then
that is general requirement. These are the
invalid.
conditions. 36, valid or invalid?
Invalid.
Invalid. Invalid. Observe, BC, Same. 36. Valid or invalid?
Valid.
Valid. See, observe here input same. 36, 36. If it is OC, invalid. If it is BC, valid. Why? Logical conditions involved in this requirement. For
Yes, sir.
example, BC again 39.
I have to see. I have to see the
3 years
age.
relaxation for BCs.
So fail, invalid.
Invalid. Actually, it is not my own. It is in government BSRB applications in Andhra Pradesh and in India, other states also. Next, BC 39 invalid. Suppose ST, observe Sri Lakshmi, ST 39. Krishna Chaitanya,
Valid.
valid. Paramita Rai, did you join? Okay, Paramita. 39. Observe Krishna Chaitanya. 39 BC invalid, but ST valid. 36 BC valid, but 36 OC invalid. Here, we can't restrict this requirement using, we can't provide input. We can't provide input for this requirement using equivalent classes and boundary value analysis only. Decisions required. Getting this point, Rahman?
Yes, sir. I'm
See,
getting.
same input.
Yes.
First 36 fail, second 36 pass. First 39 fail, second 39 pass. But based on that condition. Okay, just I will show one more example. One more example. Suppose banking system. Banking system interest. Banking system interest rates for fixed deposits. Observe the ranges 1 to 2 years. Suppose 7%. Next 2 to 3 years. 8%. Next 3 to 5 years. Suppose 10%. See, these are the rates for fixed deposits. Here one condition. Nowadays, Indian banks providing that facility. For senior citizens, for senior citizens, 0.5%. 0.5% extra interest rate for all ranges, all periods. Observe here one logical condition involved. In the first example, 3 conditions. In second example, 1 condition. Here, see, decision table. Age, period, next, interest rate. Interest rate. Suppose age 25 years, period 1 year, interest rate 7%. If it is 7%, pass. Next age 66 years, period same 1 year. Observe Rahman, what is the expected value? Expected value differ na?
Sir, I don't know the senior citizen age,
Oh,
66.
65 years
Okay.
or
Then
60 years.
7.5%.
Suppose 60 years, 5%. 0.5%
5%.
extra means 7.5%.
7.5.
7.5%. Suppose 50 years, age 4 years period, 10% interest
10%.
rate. Suppose 70 years, same 4 years, interest rate 10.5%. See, it depends on this condition, expectations vary. For that, we need to use decision tables. Okay, na Krishna Chaitanya? Decision tables.
Yes, sir.
Why you are saying dull mood? State transition testing. Ask me if you have any queries. State transition testing. Observe. In state transition testing, test cases are designed to execute valid and invalid state transitions. A system means application under test. A system may exhibit a different response on current conditions or previous history. Observe. In state transition testing, test cases are designed to execute valid and invalid state transitions. I'll show the example, then you can get more clarity. A system, here system means AUT, application under test. A system may exhibit a different response, a different response on current conditions or previous history. Example. Internet banking system fund transfer operation. Internet banking system fund transfer operation or functionality. Fund transfer functionality. Okay. Observe initial balance. For example, 45,000. This is initial balance. Next, observe transaction. Next, transaction amount. Next, valid or invalid, or pass or fail. Suppose first transaction amount 20,000, expected successful, 20,000 successful. Pass. Next, second transaction, same input 20,000, successful. Pass. Next, third transaction, same input 20,000. Abdur Rahman,
Seems like fail.
fail. Unsuccessful means pass na. Observe here. Depends on the state. Unsuccessful means pass. Why? Suppose balance is 45,000. First 20,000 successful. Remaining balance 25,000. First 20,000 successful. Remaining balance 25,000. Next 20,000 successful. Remaining balance 5,000. Next 20,000. If it is successful, then fail na.
Based on condition, yeah.
If it is successful, fail. If it is unsuccessful, pass. See, observe, same input, successful pass, same input, unsuccessful pass. Means
Yes.
depends on that condition, that state, expectations vary. This is about state transition testing.
Okay.
Depends on states, expectations vary. See, generally, if we provide same input, same operation, see, input same, operation same, expected also same, but here not like that. Based on the state, suppose balance 45, first transaction 20,000 successful, second transaction also successful, third transaction unsuccessful means pass. For example, another scenario, observe Sri Lakshmi. Input 5, 3, two inputs. Operation add. First transaction 5, 3, 8. Same input, second time 8, third time 8, fourth time 8. 1,000 times, 1 lakh times, 10 lakh times. Same expected na. But here input same, operation also fund transfer. But based on that state, expectations vary, isn't it?
Yes, sir.
See, next last one, use case testing. Use case testing. Krishna Chaitanya, what is use case? Say, based on the available documentation, we can derive test cases from requirements documents or use cases. Some companies, user action and system response. Okay, Paramita. What about your mic, Paramita? Okay. Say, any idea, Rahman? Use case? Okay, Paramita. Cool. No issue. Rahman, use case testing. What is use case? User scenario or business scenario in a dialogue between actors. User scenario or business scenario in between actors user scenario or business scenario in a dialogue in between actors. What are actors? I will explain. See, in use case testing, test cases are designed to execute user scenarios or business scenarios. See, in use case testing, test cases are designed to execute user scenarios or you can say business scenarios. A use case describes interaction between actors. A use case describes interactions between actors. Who are actors? Including users and system. User is actor, system is actor, including users and system. So in this scenario, user is actor, system is actor. Next, a use case usually has a mainstream scenario and sometimes alternate scenarios. See, a use case usually has a mainstream scenario and sometimes alternative scenarios. See, example. See, business scenario or user scenario. ATM, automated teller machine, cash withdrawal, operation. See, first mainstream scenario. Observe here, I am taking one bank ATM navigation. See, this navigation depends on banks. This ATM cash withdrawal navigation varies from one bank to another. But I am taking one bank example. Observe. Mainstream scenario. First, user inserts ATM card. Next, system. What is the system response? Rahman, system validates na and ask for pin. This is one transaction. Next, user enters pin. System validates pin and ask to select language. Next, third one, user selects language, system validates and asks to enter amount. Next, user fourth transaction, user enters amount. System just a minute, selects language, validate, asks to select, for example, select account type. Selects account type. Current account are, what are the account types, Sri Lakshmi? Current account, saving account, Paramita, saving account, current account, etc. Okay, system validates and asks to enter amount. Next, fifth transaction, user enters amount. Next, system validates next releases money. See, this is mainstream scenario. Observe 5 transactions. Insert ATM card, user validates, ask for PIN. Next, enters PIN, validates PIN, asks to select language. Next, user selects language, validates and asks to select account type. Next, user selects account type, either saving account or current account. Next, system validates and asks to enter amount. User enter amount. Next, validates, release money. This is mainstream scenario. For example, alternatives. Alternatives. See, we have so many alternatives. For example, For second transaction, Rahman, can you give me alternate for second transaction? Suppose 2A. Second transaction enters PIN. Suppose if user enters invalid PIN. Suppose if the user enters invalid PIN. Tell me, Krishna Chaitanya, what will happen?
System should reject.
System next user. Just this is alternate flow. System shows error message. For example, shows error message and ask to select. Just a minute. Ask to select. Not select. Ask to enter correct pin. Say some ATM machines provide 3 attempts. Okay, forget about that. Ask to enter correct pin. Next, user. Suppose user enters correct pin. Enters correct pin. Then mainstream. Ask for selecting language. Next, account type. Next, amount and releasing the amount. Next, alternate flow in, for example, in fourth transaction. Alternate flow. Sri Lakshmi, can you tell me alternate flow in fourth transaction? Suppose 4A. Suppose if the user selects incorrect account type. Suppose my account type is saving. If I select current account, that is invalid. Suppose if user selects invalid account type. See, already I told this navigation varies from one bank to another. I'm taking one bank example. Navigations may vary. If user selects invalid account type, then system
should send a message that it's invalid.
Shows error message. System shows error message and ask to select correct type, correct account type. Next, user suppose selects correct account type, then mainstream selects correct account type. Then mainstream. Next, observe Krishna Chaitanya. Suppose fifth scenario, alternate flow, enters amount. Okay, if user enters sufficient amount or valid amount, then system releases the money. Suppose if user enters incorrect amount, suppose fifth, another scenario, alternate scenario. If user enters incorrect amount, for example, just a minute. For example, incorrect means more than the balance. More than the balance. Suppose my balance is 10,000 I entered 14,000. So more than the balance. This is one scenario. More than the balance amount. Next, another is more than the day limit. Suppose I have sufficient funds, 1 lakh balance is there. I'm trying to withdraw 70,000. 70,000 is more than the day limit. Suppose my bank providing 30,000 or 50,000 day limit. Suppose I am trying to withdraw 70,000. It shows incorrect amount or any other message, insufficient or insufficient funds is different. Incorrect amount. The day limit is, it provides a suggestion also. The day limit is 50,000. Like, then you can enter correct amount. More than the balance amount or more than the day limit. Then system.
It should show appropriate error message.
Appropriate error message. See, shows error message. Error message and ask to enter correct amount or valid. Next, user. User enters correct amount. Then it releases the money, mainstream. See, mainstream and alternate streams. Okay, I'm going to close the session. Any queries, Rahman?
No queries, sir. Whatever I miss, I will see the video.
Cool. Krishna Chaitanya, I'm going to close the session. Any queries?
No, sir.
Sri Lakshmi?
No, sir.
Okay. Thank you.
Thank you, sir.
Okay, Paramita Rai. I will send the notes also. Okay.